In this video, we will see how to eliminate epsilon productions from the given grammar. Before that, to which production we will call as epsilon production, we will see here that a production of the form A gives epsilon. It is called as a null production or epsilon productions. So, for every context-free grammar G with epsilon productions, we can find the context-free grammar G1 having no epsilon productions such that suppose G is a grammar having epsilon productions. Now we have to write the G1, that is the context-free grammar removing the epsilon productions. So it can be like, suppose we have to find the language of grammar G1 such that language of grammar G by removing the epsilon productions. There are some rules or some steps to find the epsilon productions or eliminate it from our grammar, and that are the procedure for finding G1 means this equivalent grammar without epsilon productions from G, that is as follows. First of all, what is the first step? Find the nullable variables. Find nullable variables. Next step is addition of productions with nullable variables will be removed from our final grammar. Means first step is what? We have to find the nullable variables, and these variables means these are included in which production rules. We have to find out them and then remove it from our grammar. Then at last remove epsilon production. So these are the some steps for finding the grammar. But for specifically finding each and every part of these steps, we will see first here finding the nullable variable. Nullable variable is a new word for us. What is this nullable variable? Is how to find it. A symbol x is said to be nullable if there is a production of the form s x gives epsilon. Means the symbol or variable which is giving the production of epsilon is nullable. And if x is giving the production of alpha, then all symbols of alpha are also nullable. Means in the which are connected with the x means nullable symbols all are deleted from our grammar. To explain it, I will take one example. That is, for example, S gives ABA, A gives AA or epsilon, B gives BB or epsilon. Now, after clearly seeing A and B are giving the production of epsilon, so these A and B are nullable symbols. As the A and B all are nullable, they are in the starting non-terminus production. So this is also nullable. So all the symbols or variables are nullable. Means all this grammar is nullable. Next step is addition of productions with nullable variables remove. Means we have to remove them and then we have to write the final grammar. Now we will take example and find out how to remove epsilon productions from our grammar. First one is S gives AS or S gives epsilon. Which is the nullable symbol here? S is giving the production of epsilon, so S is nullable. I will in detail explain here what we have to perform while eliminating epsilon production. As S is giving the production of epsilon, epsilon means nothing. So by applying this, the second step was adding of productions with nullable variables removed. So with the help of that part, we can say that S gives AS, and after replacing S with epsilon, we will write S gives A. So S gives AS can be written as S gives AS is also, but it is again added with S gives small a. And we have to not directly remove these parts from our grammar, but we have to replace that part with the epsilon productions. So epsilon is removable. Directly remove that part. So epsilon is removed from our grammar, and it is the final grammar, that is S gives A, AS and S gives A. Now we will take another example, that is S gives ABA. In the previous some eliminations or elimination of a useless symbol, we were directly removing that part from our grammar, but we have to only replace that in our grammar. So S gives ABA, A gives epsilon, B gives epsilon. Clearly see here, A and B are nullable symbols, means they are removed from our grammar, but we have to replace their values in this grammar. So first of all, what will be removed? S gives ABA. Turn by turn, replace this with epsilons. For example, if we replace A with epsilon, then S gives AB is the new production. If we replace B with epsilon, then S gives AA. If we replace this A with epsilon, this production will be S gives BA. And if we remove this both from our grammar, means both A will be removed from our grammar, then our grammar will be S gives B. And if we will replace B with grammar, means B and A with same time, then S gives A again the new grammar. And now we will rewrite the grammar with we have to find the nullable symbols, but not actually remove this from our grammar part. For keep including this in our grammar, that is A gives epsilon, B gives epsilon. So this is the final answer of removing the epsilon productions from our grammar. Consider this grammar, and we have to solve it for elimination of a epsilon production from our grammar. First step was finding the nullable symbols. Here A and B are directly giving the productions of epsilon, and these are contained in the production rule of S. So S, A and B are nullable, means we have to replace them in our grammar. Second step is adding of productions with nullable variables removed. So how we can write like, first of all we will take this S gives A, B, A. Now turn by turn replace A and B's values with epsilon. So first of all, if we replace A with epsilon, then it become AB. If we will replace this A with epsilon, then it is become BA. If we will replace B with epsilon, then it is become S gives A, A. Again, if we will replace A's, both A's are removed, then it become B. And when B is removed, then it is a single A, because A is also previously described. And as S is a nullable, we are having the production like S gives epsilon. But we have to, after third step, remove it. This is the first step for this. Now, what about A? A is nullable. We will discard this part, but we have to think about this, means we will apply the productions after remove the nullable symbol. So it is A gives AA, or after replacing A with epsilon, it will become small a. For B also it is BB or B. So finally what will be our production? We will simply remove this from grammar, and this is the final answer of removing the epsilon productions from our given grammar. Thank you so much.